Hello everyone, and welcome back to the Fluctus Channel. With the rise of modern fighter aircraft, the demand for a faster and more capable electronic attack platform became increasingly urgent. Northrop Grumman engineers chose to enhance their existing A-6 Intruder into a more advanced tactical jamming aircraft. This effort led to the development of the EA-6A Intruder, which entered service in 1965 as an electronic countermeasure ECM aircraft. Following the success of this variant and the intensification of the conflict in North Vietnam during Operation Rolling Thunder, Northrop Grumman began work on an upgraded version of the EA-6A. The EA-6B Prowler, the enhanced ECM variant, was introduced in 1971, featuring cutting-edge systems capable of dominating electronic warfare. Because the aircraft incorporated more electronic warfare equipment than the original design, it was modified to support a 4-person crew consisting of a pilot and 3 electronic countermeasures officers, ECMOs. The added weight of these systems required a reinforced airframe, strengthened landing gear, and more powerful engines. The Prowler was engineered with greater versatility, allowing it to operate effectively from both land bases and aircraft carriers. The EA-6B served as the primary tactical radar jamming aircraft for the U.S., Navy, and Marine Corps until 2019, ending its service with an outstanding record that firmly established it as the ultimate prowler. Before takeoff, the EA-6B undergoes standard inspections like any other aircraft. However, the external pods mounted beneath the fuselage and wings for electronic countermeasure equipment make the inspection process more complex. During pre-flight preparations, ground crews refuel the aircraft using fuel trucks. The Prowler can carry 15,422 pounds of jet fuel in its wing tanks, while external fuel pods can store nearly 10,000 additional pounds. The pilot and electronic countermeasure officers then enter the cockpit to conduct system checks. The EA-6B is powered by 2 Pratt & Whitney J52P 408 turbojet engines embedded in the fuselage, each producing 11,240 pounds force of thrust. Although the Prowler is equipped with advanced electronic countermeasure systems, it lacks air-to-air combat capability and high maneuverability. As a result, the EA-6B remains a vulnerable target for enemy fighters and surface-to-air missiles. To enhance survival prospects, the pilot and 3 countermeasure officers wear survival vests over their G-suits to signal for rescue if necessary. Additional survival equipment is stored in a kit located within the aircraft seat. This survival pack contains essential tools designed to help crew members endure harsh conditions after ejecting and landing in remote or hostile environments. To optimize electronic attack operations, the EA-6B crew consists of 1 pilot and 3 electronic warfare officers. Two ECMOs seated in the rear operate the ALQ-99 tactical jamming system, considered the core component of the Prowler. The third ECMO, positioned in the right front seat, manages communication, navigation, and defensive electronic countermeasures. Together, all three ECMOs coordinate closely with the pilot during combat missions to interfere with enemy radar and communications, creating opportunities for Allied forces to strike. After nearly 50 years of service with the U.S. Armed Forces, the Prowler began its official retirement in 2016 with a ceremonial final flight. 4 EA-6B Prowlers from all 4 squadrons flew together one last time to honor the aircraft's remarkable legacy. The Navy retired the EA-6B in 2015, while the Marine Corps continued operations until 2019, officially concluding the golden era of the EA-6B Prowler on March 8, 2019. Since 1971, the EA-6B has played an essential role in military operations. It has participated in hundreds of missions worldwide, saving countless lives. Beyond mission success and personnel protection, the Prowler also helped prevent accidents that could have cost the Navy billions in search and rescue efforts. The legacy of the EA-6B Prowler continues to live on with pride in the next generation of electronic warfare aircraft. As the EA-6B Prowler was phased out, the EA-18G Growler entered operational service. Boeing secured the contract to develop the next electronic attack aircraft. At the time, Boeing already maintained a production line for FA-18 fighters. So 2 FA-18 Super Hornets were modified into EA-18G prototypes for testing. Following successful test results, Boeing began full production in 2007, and the EA-18G became operational in 2009. Unlike earlier electronic attack platforms, the Growler is capable of defending itself with AIM-120 AMRAAM air-to-air missiles against airborne threats. The FA-18F Super Hornet, which serves as the foundation for the Growler, includes radar cross-section, RCS reduction features that enhance the aircraft's stealth characteristics. This increases maintenance demands on the EA-18G, as ground crews must carefully maintain the electromagnetic interference shields, EMIS, canopy, and windshield coatings, and panel seams to preserve RCS reduction effectiveness. Beyond maintaining this sophisticated aircraft, loading the EA-18G Growler is a complex task in itself. Sailors from Electronic Attack Squadron, VAQ, equipped the jet's 11 weapon stations with electronic warfare pods and weapons. The Growler can carry up to 3 ALQ-99 radar jamming pods mounted under its wings and fuselage. These pods are designed to disrupt enemy radar and communication networks by transmitting electronic signals on matching frequencies, creating interference and confusion. A ram air generator located at the front of each pod supplies power to its transmitter. The ALQ-227B Communications Countermeasure Set, CCS, installed in the rear fuselage, is dedicated to disrupting enemy communications during missions. This passive system collects electromagnetic signals and analyzes them to detect incoming threats and identify hostile radar sources. In addition to countering communications, data collected through the ALQ-227B is used to locate and track adversaries. With upcoming Block 2 upgrades, the Growler is expected to receive major improvements to its electronic attack capabilities, including integration of the APG-79 multi-mode radar and the ALE-47 countermeasures dispenser into its combat systems. The EA-18G's aerial refueling capability significantly extends its loiter time, as both internal and external fuel tanks can be replenished mid-air. The Growler's refueling probe is hydraulically operated and connects with a drogue deployed from the tanker aircraft. While the U.S. Department of Defense consumes an estimated 78 million gallons of fuel annually, the U.S. Navy ranks as the second largest energy consumer within the department. In response, the Navy is exploring alternative fuel options for aircraft and vehicles. As part of this effort, the U.S. Navy's Air Test and Evaluation Squadron successfully flew an EA-18G Growler using 100% renewable fuel, naming the aircraft the Green Growler. Radar technology has become so integrated into daily life that its complexity often goes unnoticed. In military operations, radar is essential not only for detecting threats, but also for ensuring safe air traffic control. Turning off radar systems would dramatically alter the way the world functions. Military radar development began during World War II, when British scientists created systems capable of detecting incoming German aircraft. Large radar installations typically consist of massive rotating antenna arrays that emit radio waves into the atmosphere. When these waves reflect off objects such as aircraft or missiles, the return signals provide crucial data on speed, direction, and altitude. Radomes shield sensitive radar equipment by protecting antenna systems from weather, wind, and environmental damage. These dome-shaped structures resemble oversized white golf balls atop military facilities. They are engineered to remain transparent to radar and radio waves while maintaining strength in harsh environments. Radomes protect critical surveillance equipment used to track satellites, missiles, and space debris at locations such as Vandenberg Tracking Station and Clear Space Force Station. Maintaining radomes presents unique challenges across various environments. Arctic regions experience extreme ice storms and high winds that can delay essential repairs for weeks. Accessibility issues further complicate maintenance, with some locations requiring expensive charter flights and specialized transport to remote areas. Weather conditions also restrict maintenance schedules, as technicians cannot work safely when wind speeds exceed 25 miles per hour. Traditional radomes required frequent servicing every 1 to 3 years, leading to maintenance costs of up to $75,000 per visit. Radome replacement projects pose major engineering challenges that demand careful planning and precise execution. At facilities such as Kwajalein Atoll, workers meticulously remove aging protective structures while ensuring radar systems worth millions of dollars remain undamaged. Specialized cranes and rigging equipment are used to lift massive dome segments, each weighing several tons. Installation crews must work under strict timing constraints, as radar systems remain exposed until new protective shells are installed. Ideal weather conditions are essential, since strong winds can turn large panels into hazardous sails during lifting operations. Modern replacement efforts often utilize advanced composite materials that offer improved signal transparency and durability. After installation, precise calibration ensures radar performance meets operational standards with upgraded dome materials. The story of the EA-6B Prowler and its successor, the EA-18G Growler, reflects how dominance of the electromagnetic spectrum has become just as critical as control of the skies. From the Prowler's 4-person crew coordination and ALQ-99 jamming pods, to the Growler's advanced sensors, self-defense capabilities, and next-generation electronic attack systems, these aircraft have silently shaped the outcome of countless missions by blinding enemy radars, disrupting communications, and safeguarding strike forces long before weapons were ever deployed. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.